Continuing lesson 6.4, we look at the key concept on page 338. And they talk about with dot plots we can compare the shapes of the data displays or the measures of center and variability. So on this one you can kind of just look at these dot plots here and maybe see that data set A's shifted to the left a little bit, or data set B's shifted to the right a little bit more. If you look in the chart here, they actually figured the mean on both of those. So the mean, you can see data set B's got a higher mean by about 3.5. Okay. And mean absolute deviation here is pretty similar. So as far as our variability is pretty similar on both sets. And the book also talks about over here about the mode and the range. Range will tell us, overall how spread out the numbers are. Notice those are pretty similar, which we might expect since our mean absolute deviation is about the same. The mode, I don't care for the mode quite as well as some of the other things. Here the mode was 15 and 16 on data set A. On data set B, the mode was 18 and 19. But the problem I have with the mode is the mode could end up being the highest number in the data set. It could be the lowest number in the data set. That's not really going to necessarily be the best thing to describe the whole set of data. So I'm going to steer clear of the mode for the most part, unless, like on this example, they happen to be kind of towards the middle of the numbers. So look at the do you understand number 3. Two data sets have the same mean, but one set has a much larger mean absolute deviation than the other. Explain why you may want to use the median to compare the data sets rather than the mean. So since we have a large mean absolute deviation in one of the sets of numbers, means the numbers are more spread out. Numbers are more spread out, not a guarantee, but we've got a better chance that we're going to have outliers there. We talked about in a previous lesson, if you have outliers, it's better to use the median than the mean. So that's kind of one way to think about this. Another option here, this kind of just restating in different words, but the set with the larger mean absolute deviation has greater variability, and because of this, the median may represent the data better. Okay, the deal is if you find the mean, you're averaging the numbers out. You add and you divide. Well, if we have a number that's a lot smaller than the other numbers, or it's a lot bigger than the other numbers, that's really going to impact our mean. The median, it's just, what's right in the middle of all of our numbers. Put them in order, find the middle number. That's not going to be affected as much if we have an outlier. So look at the do you know how. Coach Fisk recorded the number of shots on goal his first-line hockey players made during 2 weeks of hockey scrimmage. So the first thing, number 4, they want us to find the mean number of shots on goal for each week. So for the mean for week 1, if you add all the numbers together, you get 35, and there's 7 numbers there. So 35 divided by 7 is 5. That's week 1. And then for week 2, If you add all the numbers together, you get 49, and divide by 7, which is 7 for week 2. Okay? So they averaged about 5 shots on goal the first week and about 7 shots on goal the second week. So based on the mean for each week, which week did the first line take more shots on goal? Week 2, good. Okay, 7's bigger than 5, so week 2. Okay. And then if you look at 5B, it says based on the comparison of the mean and the range for week 1 and 2, what could the coach infer? Well, the mean is what we just talked about. The range we haven't talked about here, but we could figure that out pretty quick. The range for week 1, highest number is 8, and the lowest is 2. So a range of 6 for the week 1. Week 2, highest is 9, and lowest is 5. So range is 4. Okay, so not huge difference, but which one had the lower range? Week 2. Okay, so week 1, we've got a lower mean and a higher range. Week 2, we've got a higher mean and a lower range. So if we think about that then, for 5B, so one thing we could do, we could say it looks like the team is improving and playing more consistently because their mean increased, which means they're getting more shots on goal on average, and their range decreased, so there's less variation in how many shots on goal they're getting. Okay? So more shots on goal and less changes. We want to have more consistency. Usually we'll do better in the games and stuff. So when we do these problems, they can ask us about measures of variability and measures of center. Just kind of logically think about it. Measures of variability, how much variety or how much change is there in the numbers. That deals with range, interquartile range or IQR, and the mean absolute deviation or MAD. Measures of center, it's kind of an idea of where the center of the numbers are. That's going to be a mean, which we want to use if there aren't outliers, or the median, which we will use if there are outliers. And mode is mentioned there also, but mode is not always an indication of center. Like I mentioned earlier, the mode could happen to be the biggest number or the smallest number in our set of numbers. So that, to me, I'm not going to necessarily consider that to be a measure of center when I do these problems. I'm going to either look at the mean or the median generally. You look at workbook page 81. Number 1, to analyze 2 schools in the district, the school board randomly surveys 10 students from each school to find how many hours were spent doing homework last night. Data is recorded in the table below. Which measure of center should the education board use to describe the data? Measure of center, remember, normally we're just going to look at mean or median. So for this problem, probably the best choice based off what we talked about would be to use the median because we have some outliers at Yates Middle School. Xavier Middle School, not as much outliers, but if one set or the other has outliers, then it's probably just best to use the median. And when you look at that on Yates, you might look at that and you might say, well, that doesn't really look like much of an outlier. It's just 6. It's not really that big of a number. It is just 6. The deal is, though, we have a 4, and then we have our 2 6s. Well, the 2 6s are twice as big as the 3s that we have that are kind of in the center of our numbers. Okay, so twice as much, twice as big of a number. That's why we're going to consider those to be an outliers on this problem. Okay, and then part B, what can you infer using the measure of center? So we would actually go ahead and figure out what the medians are for both of these. So we've got them in order here. So both of these have 10 numbers altogether. So if we look for Xavier as the top set of numbers, we're going to have 2 middle numbers here would be 2 and 3. If you average those out, add them together, and you get 5 divided by 2 is 2.5 or 2.5 would be our median there. And for the bottom, which is for Yates, we actually have 2 3s. Well, you average 3 and 3, you're going to get 3. So Xavier median was 2.5 hours, and Yates median was 3. So for part B, what can you infer using the measures of center then? We could say in general, students at Xavier Middle School spend less time on homework than students at Yates, or flip it around, we could say students at Yates spend more time than students at Xavier. Not significant amount, it's a half an hour difference, but it is enough that we can say that they did spend more time. So look at number 2. Heights of 10 mature plants from each of 2 different species are recorded in the dot plots below. These samples are representative of each species. So the first thing they want us to find the mean height, and that's probably okay. We don't really have much of outliers here, so that's probably not a bad thing to look at for the measure of center. To find the mean, remember you're just going to add the numbers and divide by how many numbers there are. So for A, you add them together, is 430 divided by 10 is 43 centimeters. For B, total is 390 divided by 10 is 39 centimeters. So for part B, make an inference about the species based on the mean values. So we could say just simply in general, species A is taller than species B. Look at number 3. If there was a tourist that we picked out of one of these groups and they were 46 years old, is it most likely they were a member of group 1 or group 2? Well, just look at how many there are and you can see it's a lot more likely they were from group 2. There's 5 people in group 2 that are 46 years old. Group 1 only has 1 person who's 46 years old. We look at number 4, we've got approximate distances players on 2 soccer teams had to travel to get to the field. Which measure of center should be used to make a comparative inference? These are all pretty close together. The book's saying mean, median, or mode would work. I would say they're close together. I would probably use the mean. The mean ends up being 18 1/3 for the Panthers and 37 7/9 for the Jaguars. We can visually just tell it looks like the Jaguars went further. On the mean, they actually went about twice as far as what the Panthers did. Number 5, Juanita recorded samples of the lengths of the shadows cast by elm trees in 2 of her neighbors' yards at the same time of day. The median of the sample from neighbor X's yard is 20 feet. Median of the sample from neighbor Y's yard is 50 feet. which is a comparative inference Juanita can make from the median values? Well, if the shadows for neighbor Y are over twice as long as neighbor X, same time of day and everything, then we can say that most of the elm trees in neighbor Y's yard are older than the elm trees in neighbor X's yard. Older trees, they're going to be taller, they're going to have longer shadows. So this gives you an idea of how to make more comparative inferences about populations.